All right, today we're going to talk about debugging. I've created a new app, moved the hello world down a little bit, and added a press me button and changed its ID to BTN test. Did all that before I remembered to start the recording, so that's already done. And as I mentioned in the chapter 20 exercise that I had you do, the book showed you how to create an event handler with a listener and an onClick event embedded inside it. I've always been a little uncomfortable with all that embedding of stuff. And last time I talked briefly about how I knew there was a different way. I don't know if it's better necessarily, but different way. And I want to show you that today. So I'm going to switch to the code. And I've taken out a bunch of junk that this new version of Android Studio puts in. I have not had time to analyze this, and this is the only computer, unfortunately, that I have that has all this stuff in it. So I haven't had a good chance to analyze it yet. But what I want to do first, of course, is create a pointer to the button. And I'll just give it the same name as the object itself. And that'll be equal to a button that is the same as the ID of our ID button test. Nothing new there. Make a pointer to the button. And now I want to create an onClick listener. So I'm going to say btn test.onClick listener, or set, excuse me, that's the one I want, set the onClick listener. And inside here is where you embedded an onClick listener, and it just kind of clutters everything up. So the alternative that I finally got to work, because it was inside of Wonderlic, showed me how to do it, so I'll give him the credit. I've read those first two chapters of Wonderlic, that link I sent you. If you haven't gone through those first two parts, I encourage you to. There's a lot of good stuff there, and it's pretty short and pretty sweet. I'm just going to say this. In other words, main is going to respond to that. Fortunately, when I do that, I get this red mark in my ugly red light bulb. And what Wonderlic finally taught me is, and this was causing me trouble before, but what Wonderlic taught me is just use a light bulb. And down here at the bottom, what I forgot to do is implement the onClick listener in main activity. So I'm going down to this second choice on that light bulb. I'm going to click it. And two things are going to happen. First of all, in my public class statement at the top, it's going to add the implements view onClick listener. So the main activity will do it. And then this dialog pops up, said, okay, if you're going to do that, you must have an onClick method. You want me to create it for you? Absolutely. And so what it just did is created my onClick event or method that is now linked to my button. So I can now use this for 6 or 7 buttons if I want to. As most of you have discovered, if you use this V variable, you can figure out which button it was and respond appropriately. And so this onClick view is where I'm going to do all of my testing here for debugging. So that isn't a recording, but just one more time, what I did is created a pointer to my button and then set the onClick listener to this. That gave me an error, so I dropped down the red light bulbs button and said, make the main activity an onClick listener. When you do that, you must implement an onClick method. And it gave me everything I needed except for the code inside. So I'm in good shape here. Inside here, just for testing purposes, I'm going to declare 3 integers, and I'm even going to use the simple ints just because we're testing A, B, and C. And outside of here, this is class level. I could put it way up higher, but I want to be able to see it. I'm going to define a calendar called cal, but I'm not going to instantiate it. For more testing purposes, I'm going to put some values in here. A equals 25, B equals 17. And again, to demonstrate how to do debugging, I'm going to define my own method now. So I'm going to calculate C equal to the calc mod. That's my method that I'm going to write of A and B. And I'm only writing that method so that I can demonstrate what happens when you're debugging and there's methods involved. Now it's yelling at me saying you don't have one of those. So let me create it, and then I'll pause for a second so that you can get caught up. So this is going to be a private method that returns an integer, because this said take whatever calc mod gives you and put it into C. So I have to return an integer. The name of the method is calc mod. And at least according to this, I'm going to send it two pieces of information, both of them integers. The first one I'll call top, and the other one I'll call bottom, thinking of that as a division A divided by B. Remember, that's kind of how modulus works. Whatever they were called up here, A and B, doesn't matter. Calc mod is going to refer to them as top and bottom, and curly brackets. Pardon me?
Got to return the int, yeah.
I got to return something, and that's why I'm getting a red squiggle on my curly bracket. But let me pause here for a minute for those of you trying to keep up. And now inside here, I want to calculate the modulus and send it back. So I'm going to create a temporary variable int mod, and that's going to be equal to the top modulus. Tell you what, let's just define it first, and then say mod equals top modulus bottom, and return the mod. So it's kind of a lame way to demonstrate what I want to do here with debugging. First, we better make sure it works. And so the last thing I'm going to do up here is create a pointer to my text view, which I never gave a name, so I better go do that. I'll call this TV results like I always do. And back to the code. Text view TV equals text view find by ID r dot text view results. And I'm keeping it simple because the point here is not to write complicated programs, but to be able to test stuff. And a quick run to make sure it works. Okay, so I already clicked on the press me button and everything is cool, except when I initially created this, just from the recording perspective, in case you didn't catch it, I accidentally named the layout view, the relative layout TV results instead of the button. I didn't click carefully enough. Okay, so this works. So now back to my notes here. Anybody need me to hold on? Back to my notes, let's talk a little bit about debugging. Android Studio comes with 3 different tools that we can use to debug. The most commonly used one is the debugger, and that's what we're going to spend a fair amount of time talking about here. Then I'll show you quickly how to use the log file. Occasionally your program, the debugger doesn't help you, particularly if there's logic errors. Sometimes the debugger doesn't help you because you don't quite know the order that things are happening. The log file allows you to write messages to this log file down here, to the logcat, so that as your program is running, it's leaving little messages for you in there. For you, the developer, any messages that are written to the logcat are never shown anywhere on the screen when you submit your application to your application to the Google Store. It has no effect on anything. I don't think it's even in the compiled version. It only works when we're debugging and when we're inside the IDE. I'm sorry, the log file does work even when we're not debugging. And finally, there's Toast, which is basically Android's version of the message box. And occasionally that can come in handy. If you can't quite figure out what your program's doing, you can put in Toast messages to display something. First and foremost is the debugger. And this debugger works very much like the debugger in Visual Studio. It actually has a few cool features that I find pretty handy to make life a little bit easier. What we're going to do with this debugger is set breakpoints. And the concept of debugging, a breakpoint is a place where you want the program to stop while it's running so that you can look around. You, being the programmer, so that you can look around and see what the contents of variables are. And once the program has stopped, then you can start using some of the other commands we'll see here in a minute that allow you to step through the program one line at a time and continually watch to see what it's doing. Before class, John and Kevin and Lyle were back there working on a program that couldn't quite get it working. Wasn't doing what they expected it to. The syntax wasn't a problem, but the program didn't seem to be doing what it wanted it to do. So we put a breakpoint in, and then we stepped through it to watch what commands it was touching. And when we hit the if statement, it went from the true, it didn't do the true part we expected it to, but it didn't do the true part and jumped right to the false part. And that gave me at least a clue that there's something wrong with that if statement. And so that's what the debugger is designed to do, is to help you take a look at your code and try to figure out why it's not doing what you think it should be doing. Now in this case, I don't have any errors in my program that I can think of, but we can at least look at the demonstration. The key to using the debugger, and this was an eye-opening event for those guys back there, is you can't run. When you're doing a run, the debugging, breakpoints, etc. are ignored. You must use the little bug next to it and run your program in debug mode. All right, so just as an example, I'm going to put a breakpoint on this line. To insert a breakpoint, first of all, I recommend you turn on the line numbers. We'll see why later when I do make an error. To turn on line numbers, you can right-click and show line numbers. I'm guessing there's a setting someplace where you can say always show them, but it's so easy to do it on the fly that I don't usually bother turning. I haven't found that setting yet. To set a breakpoint, just like in Visual Studio, you simply point to the gray area over here to the right of the line numbers, to the left of your line where you want the breakpoint to be set, and click, and it sets one. Now let me also put in a little caveat here. I'm going to show you some of the basics of debugging. There are probably more advanced techniques, but I never use them. These get me to the point where I need to be when I'm looking around and can't figure out why my program doesn't work. So my program now has a breakpoint in it. Just as a demonstration, when I run, and notice it's in the onClick event. So in order to make this breakpoint work, I have to click. But first of all, let me run it. And that's a mistake, right? Because when you run it, the program doesn't pause. So that's a very common mistake. If, however, I use the debugger, you're going to get this message all the time. Just wait. It's just telling you it's communicating. And now if I click, the program pauses. The next line to be executed is highlighted. That line has not executed yet. My program has paused. couple of cool features that are available in Android Studio that we didn't have in Visual Studio is, notice right next to this line here, it's telling me the values that are inside of B and A. So that's my first clue. It's my first ability to look around and say, hey, that's cool. 17 and 25, as I expect. The other thing to keep in the back of your mind is this line has not yet executed, and that's why it's not showing me what's in C. Notice even the declaration up here says B's got a 17 in it, A's got a 25 in it. I can see the values of these variables in lots of different places, including the variables themselves. I can go anywhere and touch them. Hover. I have to click in there. There we go. And it'll show me what's inside there. So if this is 100 lines away and I don't want to go look at it, and I just want to see what's inside a variable, I can hover on it and it'll tell me what's inside. But I think this feature here is pretty cool. I don't have to hover anymore. So that's a breakpoint. And your ability to look at the contents of variables. Let's see what else I got in here. When your program encounters a breakpoint, runtime will stop. Android will switch to debug mode, which is the mode that we're in here. Notice the bottom of my screen now has a debug window pane. And inside there are a couple of tabs and frames. Okay. Here's the variables frames. For the method that I'm in, this shows me the contents of all the variables for the method that I'm in. Notice it's not talking about top and bottom, it's only talking about A and B. If I walk through this program and end up in Calc Mod, then this is going to change, this view is going to change and show me the contents of top and bottom and mod. So it's another key point. You can only see the variables in the method that you're in. If you want to see variables in a method that you're not in, then you have to use a watch, and we'll save that conversation for just a minute. So the debug pane is open down here. 3 tabs, debugger, console, and what was the other one supposed to be? Logcat. For some reason, I don't see a logcat here. Uh-oh.
Android monitor?
Don't think it's going to be hiding in here.
Android monitor. Number 6,
It's the event log. It's not quite the same as a log cat, I don't think. Maybe. Those are events. Oh, I should have never upgraded. I wonder if there's a way to go back. Probably not.
You're looking at the Android monitor now? It's either an Android monitor or one.
Yeah, it's probably that one. So, okay, here it's called the Android monitor. And now that I brought that up, here's the log cat. But it's switched. So here's my debug window. So it's a little bit different in this version, but in the version that you're using, you should see 3 tabs across the top here. One that includes logcat so that you can bounce back and forth when we start using the logcat. But we're not there yet anyways. We want to use the debugger, so make sure that it's selected so that you can see the variables pane and the watch pane. There's many frames in here. This is the variables frame. There's a watches frame over here. This one I don't use much. The frame, I don't even know what half this stuff is. So I can collapse it, get a little more view in the debugger so you can see your variables a little bit better. Sometimes it helps, and you got plenty of room here so you can stretch this one. These are the debugger toolbar buttons. They're disabled until you run. There's a couple of them on the left. Well, let's talk about those later. So right now, these are enabled, but if they're disabled, it's because you haven't run in debug mode yet. If you run in run mode, they don't show up. The only time they light up is when you are paused in debug mode. First button I don't use for much. This button we'll talk about steps over. According to my notes, set the breakpoint, did that already. Saw the values, that's good. What else am I supposed to talk about? Can hover, only variables in the current method are displayed, talked about that. Complex variables like classes are a little tougher. Right, but they will often show up here and they have a little arrow next to them, kind of like V and this, and you can expand them and see what's going on. V is my view, so this is an implement. This shows me all the details about the view. But if you have your own, most of you are doing alone. If you're having trouble debugging that and you have a lone object and you want to see what's in that object, it'll have a little arrow to it just like that. And you can look inside and see what each one of the members has. Do setting watches in a little bit. Okay, so here's the buttons. The debug pane has these buttons. I don't use the first one, but I do use this one quite a bit. Step over is the most commonly used debug button. What it says is execute the next command. If it's got any module calls in it, like this one, or method calls in it, like this one, just go do them and come back. Step over this command and execute it. So I'm going to do that. Click, and notice now the blue line moves down to the next line. That's the next command to be executed, and now C has a value. And I can step over, and watch my program execute. And if I have if statements in there, I can watch it jump from the if statement to the else, from the if statement to the true part. If it's a loop, I can watch it go back up and execute, and go up and execute, and go up and jump out of the loop because it's done. And I can watch it to see if it's doing, if this program is doing what I expect it to do. You wrote the code. In most cases, you write it because of the logic that you've come up with. Obviously, if you're testing in debug mode, there's something wrong with your logic. This will help you. It'll show you what the program's doing compared to what you think it's doing. But you, the programmer, have to have an idea of what you think you want it to do. So I can step over, and now this should be displaying somewhere on the screen. And if I want to see the end results at this point, I can hit the run button. This run button, not that one. If you hit this run button, it will recompile your program, reload it into the emulator without debug mode, and yes, you'll maybe see the results. But what I want the program to do is just continue on as if I had never interrupted it. This resume button, and it is described in my notes a little later, the resume button says run the program without stopping unless you hit another breakpoint. You can have as many breakpoints in your program as you want. Usually they're pretty strategically placed. You can have as many as you want. So you can say break here, and then 100 lines later put another breakpoint in, and you can jump from this line to the next line with a breakpoint on it just by hitting run. In this case, I don't have any breakpoints, so my program is still running. And normally I'd have this on the other screen, and now I can see the results. So that's what that run button is for. If I click press me, it'll go through and calculate the modulus again, but it'll pause at the breakpoint again. Every time you hit that line while your program is running, it will pause. You can remove breakpoints while the program is in debug mode. You can change the code. I did this last night, cost me 45, not that long, about 20 minutes of wasted time. I changed my program and said, no, I want this to be 27. While it was in debug mode, and then I'd run it, and it never gave me the new mod never gave me the updated answer. That's because it never recompiled the program. If you change the program, my advice is hit the stop button that stops debugging, modify your program, and then debug again. Now I removed my breakpoint, I didn't mean to. Once my debugger goes, it'll sit there, and I can add a breakpoint at any time. So breakpoints you can add whenever you want to, but don't go changing code without recompiling. There's my break again. Now back to these toolbar buttons. This one was step over. There is a method call in here, calculate mod. I think it's working, But if I'm not sure, I can actually watch this program jump into this module and do whatever it's doing. That's this one, which is step into. What step into says is execute this line, but if there's any method calls in them, go inside the method so we can walk through the methods one line at a time. Why wouldn't we just want to do that all the time? A lot of methods, remember Volcker tools? A lot of methods written by somebody else. Why would you want to debug inside of Volcker tools? It's been blessed by me and 700 other students. Shouldn't be any problems in there. If you're at Skyward, there are millions of methods that somebody else wrote. You don't need to debug those methods. You just step over. But if it's one of your own that you wrote and you want to see what it does, then you do a step into. And notice where my program now has gone. It has jumped into this method. It is giving me the values for top and bottom. Notice they're the same values as A and B because I sent in A and B. If I go back to my debugger mode here, notice A and B are no longer showing because they are not in the current method where my line of execution is. How come there's no value for mod? Because we haven't executed this statement yet. It's a very common misperception that this is the last line that was executed. Nope, that's the next line to be executed. So once again, I could step into, or now I could go back to the step overs. Notice the shortcut keys, they're different than Visual Studio. It's annoying, but it's a different program. Why would they be the same? F8 and F7, you can use the keyboard keys to step through these. Instead of click, 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 you go F8, 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 F8. If you can remember them all, great. In this case, there's no method call here. So step into and step over are exactly the same. Doesn't matter which one you use. If you get real good at this, you realize that my mouse button's already on here because I just stepped into, so I can step over that one. And then it recalculates, and mod now has a value of 9. Returns mod. Mod has a value. Everywhere it shows up, it's got these numbers next to it. Doesn't seem to slow things down just a smidge while it refigures out all these values. But now when I step over or step into, doesn't matter. Again, there's no method call. It will go back up to there where I came from. And notice now my variables, once again, have changed. And I have to do one more step into or step over to get past that line. So what happens is when you step into, it goes down to the method, executes the method, and when you come back, it hits on that same line, and you have to tell to get past it. I'm going to run. And I'm going to go to my app and hit the button again so that I hit my breakpoint again. There's my breakpoint. If I step into and go, oh, dang it. And this will often happen. You'll step into one of the Skyward methods that's just over convoluted that nobody can read. And there's no way you're going to debug it anyway. You go, darn it, I was supposed to step over or I stepped into. The red arrows, or no, sorry, the blue arrow tells me, no, never mind, get me out of here. So you can get out quickly. So this is kind of the counter to step into. It's an oops button. Oops, I stepped into. I don't quite, this one's new to me. I've not seen anything like that in Visual Studio, a forced step into. I don't know what I would want to force myself into that this didn't do for me anyways. I don't know. Maybe there are some built-in classes in Java that I don't step into. I don't know. And I want to force it because I want to debug the Java method? Probably not. So I'm not quite sure what this one is. If you look in my notes, I stole the text, but I don't really know what it's for. And I didn't do any research. Again, I'm giving you the basics here. Set a breakpoint. Step over, step into, step out. That's normally what you're going to need. Questions so far? Old news or help clarify things? Kevin? I see your eyebrows going up. That helps. Where was this a year ago? Well, I was a rookie instructor that I'm much more seasoned now. That can help with a lot of things. Exactly. Okay. The one thing I don't have in this example is my own built-in class Can you put breakpoints in the class methods? Absolutely. I can put a breakpoint inside this method. Notice I just added it. And now if I run my program, come back here, I can click on it and say, press me, and it stops there. Then I can say run, and it stops there. And I can put breakpoints in strategic locations so I can say, yeah, this looks good. Let's go to the next place. And yeah, this one doesn't look so good. More often than not, for me, it's stop here because I know something is not working right. For those guys, it was an if statement. They wanted to know if the string that they sucked off the form was empty. And they had an if statement, and the program kept saying, no, it's not empty. No, it's not empty. But they left it empty. And so we put a breakpoint on the if statement, ran the program, left the text box empty, the text view, no, pardon me, the edit text empty. Hit the button, the calculate button, and hit the breakpoint. Stepped over and went to the else. That was not what we expected. So that helped us narrow it down. What they had said is if the text dot get text double equals the empty string. Doesn't work in Java. They got a false, even though it was. You have to use the isEmpty method to find out if a string has the empty string in it. But it helped them narrow down where the problem was. And they could have emailed it to me and said, this line, darn it, doesn't work. Every time we leave it blank and step over, and then that narrows it down for me too. I can look at that one line and say what's going on. Step into, step out, resume, and stop. Again, if you're going to modify the code, you go, oh, that's what's wrong, and you're going to fix it. Don't just fix it while you're in debug mode. You're allowed to. But if you keep then debugging with the same execution, it won't sense your changes. You have to stop the debugging, and no, it doesn't stop your app. It's still there. And you can keep playing with it, but you're not debugging anymore. Now that it's stopped, now you can make changes and then run again and maybe put breakpoints in different places. Setting watches. If you have a complex variable, like the calendar, the debugger can't show you what's inside. Now, I'm kind of curious here. What happens if I make these integers? Let's put a breakpoint in here. I want to see if it actually shows me these. I had a suspicion that it might not. Oops. Notice I immediately clicked the debug button. Hopefully it'll put me in debug mode here. Should give me that warning saying I'm waiting for the debugger. Nope. Start again. There it goes. So it actually ran it. Now it's running it again in debug mode. There it is. If you don't see that, you forgot. It always shows up. It always shows up even on an external device. I finally got my Nexus 7 working on my Surface and on my home computer, so I'm being much more productive. What was I doing? Breakpoint because of, integers. There they go. Got quotes around them. That's interesting. What does that tell you? That the integer class stores your numbers as strings?
How do they show up how do they show up in the variable window? Under the definer.
As strings?
For classes.
Yeah, they're definitely classes, right? But the fact that they come with quotes around them is interesting.
It's a two-string.
Right. And the good news is you can at least look inside. Yeah, you're right. That's a very good point. This is a two-string. What happens if I two-string this int? This is what I'm going to get. But not all classes work that well. I'm going to stop my debugging. And underneath here, I'm going to define my calendar. As a new instance of the calendar, and then just for grins here, I'm going to say calendar.add the calendar.date. Type. And we'll add 15 days just for grants. I'm going to set my breakpoint down here because I want it to go through all of this. I want to see what's in that calendar. I put all of this in an onClick event. I could have put it in onCreate, and then it would pause and stop right away, and I wouldn't have to go through all this clicky stuff all the time, but that's okay. It just gave me a chance to show you how to do a different onClick event. Okay, there's my breakpoint. This thing is probably thinking, and there's my 9/17/26. What the heck is in my calendar here? Something very long. There's the year, there's the month equals 10, and there's the day of the month. What? Oh, that's Monday. Day of the week. Boy, that's kind of confusing, isn't it? But at least you can look inside. But one of the things I've discovered, and again, if you look down here, it's the same problem. And you can look in here, but it's not real helpful either. Zones and all kinds of stuff, and here's some fields, and there's fields that are numbered. What the heck? But I can see a 2015. I can see a 10. And today is what, the 19th? 18th, 19th. Today's the 19th. So I don't think that's it.
15 days after that, though.
Oh, that's right. Thank you. I bumped it up. That's why that's 15 days is month 10 from today. It'll be the 31st. Oh yeah, that's month 10, isn't it? Right, Karen? 15 days from today is month 10? Because it's November.
Yeah.
Okay, so yes, I forgot about adding my 15 days here. 15 days on to the 19th is the 4th of November, 3rd of November. So that's probably the 3. It's hard to, where is it? Geez, that's hard to tell. It's got to be a better way. There is. We can set watches.
Oh, yeah.
Should be able to set a watch. Now I got a new problem.
You called me when you said it's month 10. I was like,
It is month 10.
Starts at 0.
Starts at 0.
Yeah.
To add watches, there's a little plus sign down here. We can add a watch. And you can type any expression in here that you want to. Any expression. So I could do something like cal.getTime. Oops. And now I can read it a little bit better. I don't know that I could have created a date formatting. That's not the point, right? To make this pretty is not the point. But this is a little over the top for me to figure out. Figuring out in here who's the month, who's the day, it's hard to tell. This at least gives me something I can read. If I then step over and step over, notice the cal is still there. Why is the cal still there? Even though these other ones have changed, the cal is gone because I set a watch for it. It's a global variable that is not being used at this point anymore, but it's still showing up here. So once you set a watch, it'll keep looking at those variables. So if I define a watch, I'm still inside this method. Let's add another watch, and you can set as many as you want for the variable A. It tells me there's a 26 in there. But watch, and let's see what happens to top. Oh, come on. Can't find it. But if I run, and I hit my button again, I went too far with my breakpoint. Still no top. Now if I step into, it goes, oh, top's got a 26 in it. Now there's no A. It's in a different method. But you can always see the calendar because I defined my calendar as a class level variable. I didn't put a private in front of it, probably should have. It's a class level variable. It's outside all of the methods. So I can always see what's inside of it. if you want to keep an eye on the loan amount inside your loan, no matter where you are. Put it in a watch and it'll always show you what's in there. Occasionally it'll change and you go, what? Who changed that? And you can watch it. Yep, still right there. Oh, it just changed. As you're stepping through your program, all of a sudden that changes, and it might be a side effect of some other command, and you can find out which command is causing that side effect. So that's where the watches can come in handy. Again, this can be any expression. I can add a watch for top plus bottom. Any expression. Even if you're not using it in your program, doesn't matter. Questions about watches? Okay, that's a good place to take a break. When we come back, we'll do a little bit of log catting and a little bit of toasting. See you then.